In this example, we will anti-differentiate secant cubed. Now, corresponding to this hint, or looking back at the table which gives us guidelines for evaluating integrals with powers of tangent and secant, since we have only an odd power of secant and no tangent term is present, the hint is to use integration by parts. So we're going to go ahead and rewrite this. And when you're going to apply integration by parts to an odd power of secant, the best way to do so is to rewrite it as secant, in this case, times secant squared. The reason being is, now if you think about applying integration by parts, we need dv to be something that we can easily anti-differentiate, which secant squared is. So if dv is secant squared, v is just tangent, u is going to have to be secant, and du would then be secant tangent. So now applying integration by parts, we have uv, so secant tangent, minus the antiderivative of v du. So the antiderivative of v du would be tangent multiplied by secant tangent. So that would be a secant times tangent squared. And now what we'd like to do is somehow evaluate this resulting integral. The secant tangent part is just going to come on down. But in order to integrate secant times tangent squared, this is actually a fairly difficult integral. Unfortunately, it doesn't correspond to any of the first four guidelines in our table for evaluating tangent to a power, secant to a power. So the next choice would be to write it in terms of sines or in cosines, which certainly works here, but I think we can get where we would like to go a bit more quickly if we just rewrite tangent squared as secant squared minus 1. So kind of just continue on using these Pythagorean identities. So secant squared x minus 1. And what I'm going to do is go ahead and inside the integral, I'm going to distribute the secant to each term, and then I'm going to break up into two separate integrals. So secant times secant squared is secant cubed, and secant times minus 1 is minus secant, but because of the minus sign out front, it's minus a minus, so the integral of secant. And looking at the two integrals that have resulted here, the antiderivative of secant isn't a problem. That's actually one of our common anti-differentiation formulas. And minus the integral of secant, well, that's the integral we're trying to evaluate in the beginning. So everything that we have here is actually equal to the antiderivative of secant cubed. So what we can do, much like we've seen in the past with some of our integration by parts problem, is we can think about this integral of secant cubed, the thing we would like to solve for, we can just algebraically isolate it. So I'm going to take the term which is on the right, and I'm going to add secant cubed to both sides. So on the left, we would have 2 secant cubed, 2 integrals of secant cubed, equals the secant x tangent x, plus the antiderivative of secant, which we'll go ahead and replace that with natural log secant plus tangent. And then the last step is going to be to isolate that antiderivative of secant cubed. So multiply both sides by 1/2. So 1/2 times the quantity, secant tangent, plus natural log absolute value secant plus tangent. And then of course this is an indefinite integral, so we make sure to include our plus c. From an overall big picture perspective, the antiderivative we started with was secant cubed, so an odd power of secant with no tangent present. So the technique that typically will apply in this situation is integration by parts.